uh, a lot of things related with human activity, like human beings' IQ score, human beings' height, weight, and uh, for students' performance for a specific course, for your final exam distribution, they all normally distributed. And also normal distribution is a kind of foundation for STATS. And in next chapter, we will talk about the central limit theorem. After central limit theorem, we will find out if no matter the original distribution is normal or not, if our sample size is large enough, the distribution for the sample mean is always normal distribution. Okay, so we can use normal distribution to help us to deal with a lot of inferential stats part. And for normal distribution, it has three characteristics. The first one, you need to remember this. Normal distribution, it always follow bell-shaped curve. And for this bell-shaped curve, it's symmetric. It's symmetric with respect to the mean. Okay, so for me, I use mu to represent. So it's symmetric with respect to the mean. And because it's symmetric, so mean is equal median is equal mode. So if I give you like x follow normal distribution with mean equal 2, with the standard deviation is equal 0.5, what is the median of the random variable x? The median value is equal to. What is the mode for this random variable value? The mode also equal to, because mean, median, mode, they are the same for normal distribution. And for the mean is the axis of symmetry. So we can get the area under the curve for this part is equal the area for the green color shaded part. They all equal 50%. So for this part, I have 50% of observation less than the mean. And for this part, I have 50% of observation bigger than the mean. Okay. And for today's class, I will show you how to use this 50% to help us to get some probability value. Okay. And at the end of the lecture for Tuesday's class, I showed you the density function. And for this density function, I use the online graphing calculator and showed you what if I change the value of the mean, what happened? If I change the value of the standard deviation, what happened? Okay, so now I will give you a summary. Okay, so we have x follow. If we have x follow normal distribution with mean equal, how about I just use a general notation? The mean equal mu, the standard deviation equals sigma. Mu, it can be any number, and for sigma, also it can be any number. Okay, and if I have the mean fixed, if I fix the value, how about at first I fix sigma. Okay, if I fix sigma, if I change the value of the mean, I can find out for my bell-shaped curve. For the bell-shaped curve, the shape, it doesn't change. It looks more or less it has more or less the same shape. I will use another color. They have the same shape. And this is another mu. So how about this is mu2 and this is mu1. Okay, so if mu2 is bigger than mu1, it's kind of I do a horizontal transformation. If mu2 is less than mu1, I also do horizontal transformation. I will transform to another side. So if sigma is fixed, okay, the shape, it doesn't change. Okay, the shape doesn't change. And if I change the value of the mu, if I change the mean value is corresponding to the location. Is corresponding to the location for the bell-shaped curve. If I change the mean value, I need to change the location. Sometimes I move it a little to the right, sometimes I move it a little to the left. Okay, so if standard deviation is determined, I cannot change the shape, but I can change the location. The first conclusion. The second conclusion, I will zoom it a little bit, I will write here. So the second one, how about I fix the mean value? Okay, if I fix the mean value and I change the standard deviation, I will use red color. Okay, so for my original graph, so how about I choose the standard deviation equal 1. So I will sketch the graph. It roughly look like this. Okay, if I change the standard deviation last class based on the output from the graphing calculator, we know sometime for the peak it become bigger than before. Sometime the peak it become smaller than before. Okay, and because normal distribution is continuous random variable, so if I change the height of the curve, if the height of the curve is changed, if it become taller, it will be narrower. If it's shorter, it will be wider, because I need to make sure the area under the curve it always equal 1. Okay, so this is very important. We need to remember the area under the curve it always equal 1. So we need to make sure the area equal 1. So if our bell-shaped curve it become taller, it should be narrower. If it's shorter, our bell-shaped curve it should be wider. It should be wider. Okay, and if we fix the mean value, that means the axis of symmetry. The axis of symmetry, I use yellow color. The axis of symmetry is fixed. So no matter the blue curve, the red curve, and the green curve, they have the same axis of symmetry. Okay, and the change is the shape, right? So if we have sigma changed, if sigma is changed, we need to change the shape. Okay, the shape, sometimes it become taller, narrower, sometimes it become shorter, wider, but the location doesn't change. The location does not change because the mean value is determined, right? The mean value is determined. I know the center of the bell-shaped curve. They have the same value. Okay, now I will talk about when it becomes shorter, when it become narrow, when it become like a wider, when it become taller. So if I will zoom it a little bit. If our sigma value is larger, sigma value is larger. Sigma value, that is standard deviation, right? Standard deviation, it represents the spread of the data. So that means it has bigger spread. It has bigger spread. That means our bell-shaped curve should be wider, right? If it's wider, it should be shorter. So it will be shorter and wider if sigma is larger. So corresponding to the curve, it will corresponding to this blue curve. Sorry, the green curve. It should be shorter and wider. If our sigma is smaller, okay, our sigma is smaller. That means the variance is smaller. Our data have small spread, right? If it has small spread, that means our curve should be narrower than before. So if it's narrower, it should be taller and narrower, so that the area under the curve is still equal 1. Did that make sense? For the change of mu, that is easy to get. If it's bigger, it goes to the right side. If it's smaller, it goes to the left side. And how to understand the change of the standard deviation? The standard deviation, we need to build a connection with the definition we covered in previous chapter. Standard deviation is larger. That means variance is larger. That means the spread is bigger. The spread is bigger, our curve should be wider. Our curve is wider, it should be shorter, because I need to guarantee the area under the curve is still equal 1. Okay, if that makes sense? If you have any question, you can unmute yourself, talk with me. Okay, so this is the probability density function. And the probability density function, we need to be careful about the 2 parameters, the mean and the standard deviation. If I change mean, if I change standard deviation, it will change the shape, it will change the location of the curve. Okay. And for normal distribution, there is a special type of a normal distribution. We call it standard normal distribution. And for standard normal distribution, normally we will use capital Z to represent our random variable. Okay, and for capital Z, in the future, if you see this notation capital Z, it represents standard normal distribution. It is a special normal distribution because we have special value for the mean. The mean is 0. We have special value for the standard deviation. Standard deviation equal 1. Okay, so our notation is Z follow normal distribution 0, 1. So in our mind, we need to know if we have standard normal distribution, it's still normal distribution. We just have a special mean value, special standard deviation value. It's still a bell-shaped curve. We just have the mean value equal 0. The mean value is given. The standard deviation value is equal 1. It's also given. Okay, and for Z, that is a notation for standard normal distribution. And for X, that is a notation for general normal distribution. And there is a connection between normal distribution and standard normal distribution. They have a connection. We could use the following algebra to build a connection with the mean and the standard deviation. For build a connection with the general normal distribution with special normal distribution. And for the mean, if our X follow normal distribution with mean equal mu, with standard deviation equal sigma. And if we want to transform this to standard normal distribution, and for this procedure, we call it standardize. Standardize. Okay, and this is a very important step for data analysis. If you have a data, for example, I want to analyze the data regarding human beings' height and human beings' height and the relationship between human beings' height and human beings' weight. Okay, and based on our life experience, we know if a person taller, we expected to say the weight is bigger, right? And for the height, if it's given like this is equal 170 centimeter. If we use different units, okay, if we use a centimeter, we can get the height. If we use millimeter, we can get another value for the height, right? So if we use millimeter, we know our height value will be much bigger than the height value if I have the unit like a centimeter. Okay, so that's why if I do the standardized value, after I do the standardized value, I use every number minus the mean over the standard deviation, I can get standardized version of my random variable. It will be easier for me to do the analysis. Did that make sense? And also, if this part, if I use centimeter, is 170. If I use millimeter, is 1,700. I know for larger value, sometimes it will dominate my result. So if I do one step, I standardize my value, my model will look much better. Okay. And how to do the standard? How to get the standardized version for the random variable x? If we have x, for example, I still use the height of human being, 170, 180, 175, 178. How about 192, 167, dot, dot, dot. Okay. And how to get the standardized version? I find the mean for this distribution. I find the mean value, and then find the standard deviation value. Use my original data. For example, if this question I get the mean value is equal 175. For the standardized version, for 170 is equal 170 minus 175 over standard deviation. If suppose I find the standard deviation equal 5. So this number divided by 5. So this is a standardized version for 170. So I can find out the standardized version. 170 minus 175 is equal -5. -5 over 5 is equal -1. So it can make our value into a much smaller range. Maybe my original value, it varies from 150 to like 220 centimeter for the height of a human being. And if I do the standardized version, I can find out majority of the data around 0. So it will, maybe the range is from -4 to +4. If I have a data is 180, if I want to get a standardized version for 180, I use 180 minus the mean over the standard deviation. So it's equal +1. So we can say for original data, for the raw data is 180. After I clean my data, after I standardize my data, I can get is equal 1. So it will be easier for us to do the analysis. That makes sense? So that is the one of the main reason why we want to standardize our data. Okay. And how to standardize? Use this formula. The mean, if for our test, we always give you the mean. We always give you the standard deviation. Okay. How about I give you one example? You can try this example by yourself. For example, if I already know for human beings IQ score, follow normal distribution with mean equal 100, standard deviation equal 5. So we do a standard test to get a score for human beings IQ. And if we have a human, and for this human, his or her IQ score is equal 110. Okay, could you find standardized value of this IQ score? How to find the standardized value of this IQ score? And for standardized value, you can also call it Z value. Okay, so this is equivalent to the question, what is Z value? Of this IQ score? If you get a question like this, we just have one formula, right? We just plug into this formula. We have this formula. We want to find the z value. We want to find the standardized value. So z is equal the original data, which is 110, minus the mean. The mean it gives us, right? This is mu. This is standard deviation over standard deviation. So it's equal to. Does that make sense? So we can transform a data from a very large range to a smaller, much smaller range. Okay. It's also okay. We can have like, if we have a human being, the IQ score. So how about I change the IQ score a little bit? If I have IQ score for a human being is equal 80, what is z value corresponding to this IQ score? They still do the same algebra, okay? We use 80 to replace x, and the mean value is 100. Standard deviation is equal 5. So it's equal negative 20 over 5. It's equal negative 4, okay? So for this example, it gives us a clue. For z value, it's okay to have negative number. If the original data, if the raw data is less than the mean, our z value will be a negative number. Okay, so sometimes z value is positive, sometimes z value is negative. Any question about this part? How to, if we have a x value, if we have a original data, how to get z value? How to get the standardized version for the data? If you don't have questions, I will give you one example. You can practice this one by yourself. Okay, don't have a look at my solution. Suppose you cannot see this part. Okay, try it by yourself. I will give it 2 minutes. You can have a look at this question. Okay, so if you get a question like this, quickly find the keyword. Okay, the mean is something, standard deviation is something. Okay, so be careful about this part. Sometimes we give you standard deviation, sometimes maybe we give you variance. Okay, so if I give you variance is equal 40, 100, 4,000. No, 40, it should be 40,000, right? The square of 200 is 40,000. So if I give you the variance is equal this, you need to transform variance to standard deviation as your first step. Okay, so be careful about which information it gives you. If it gives you standard deviation, that's nice. You don't need to do any calculation, right? You already have the standard deviation value. You just need to plug into the formula x minus mu over sigma. The value of x, we have two parts. The first part is x equal to 1,200 minus the mean 2,000 over standard deviation, which is 200. So that is 200 over 200 is equal. That makes sense? So if you give me this full credit, that's all you need to do to find z-value. Okay, so this is our first objective for this chapter. If we give you a data, how to find z-value corresponding to this data. Okay, and the second value of x is 1700 minus 2000 over 200 is equal negative 300 over 200. So that is negative 1.5. So this is a z-value for 1700, right? Z-value corresponding to 1700. So we can say original value is 2000 something, it become 1. The original value is 1700, it become negative 1.5. So we can transform our data into a much smaller range. That makes sense? Okay, so you will have similar question for our exam. Okay, how to get a standard version for the data. Okay, so if you don't have question for this part, now I will talk about the rule. And for this rule, it is the beautiful part for normal distribution. Okay, and for normal distribution, we know it's a bell-shaped curve. So that's why we have this bell-shaped curve. Okay, and how to read this chart. And for empirical rule, I give you in two methods. The first method, I use a graph. So if you are a visual person, you can just remember this graph. Okay, if you are for empirical rule. Okay, so what's the meaning of empirical rule? We know normal distribution is a bell-shaped curve, and it's closer and closer to the middle part. It's closer and closer to the center. How about I use black color? Okay, so if it's closer and closer to the mean, we will have more and more observations. Okay, so we have, based on a lot of experiment from statistician long time ago, they got this conclusion. We have roughly 68% of observations between mean minus 1 standard deviation to mean plus 1 standard deviation. Okay, so that means if I have x follow normal distribution with mean equal, how about 100, standard deviation is equal to, okay, from 98 to 10 and 2. In this range, I have 68% of observations. Okay, and between mean minus 2 standard deviation, mean plus 2 standard deviation, we can call it a 2 standard deviation range. Okay, in this range, we have 95% of observations. From 96 to 104. Okay, mean is 100 minus 2 standard deviation to mean plus 2 standard deviation. We have 95% of observations. And from mean minus 3 standard deviation to mean plus 3 standard deviation, in this range, we have 99.7% of observations. So that's mean from 100 minus 6, that is 94, to 106. In this range, I have 99.7% of observations. If my distribution is a normal distribution with mean equal 100, standard deviation equal 2, I can get this conclusion. Okay, so for this empirical rule, it's widely used for quality control. Okay, so if I, for example, if I'm a manufacturer regarding I produce how about a laptop, okay, or how about I produce an iPad? If we have a manufacturer of iPad, okay, and if we know for the battery of iPad, it can last around 10 hours. Okay, I'm not sure. It's just a fake number. Okay, so the battery can last with mean equal 10 hours. With standard deviation is equal. How about 20 minutes? 20 minutes. Okay, so the time of the battery could last is normally distributed with mean equal 10 hours, with standard deviation is equal 20 minutes. Okay, so we can get a quick conclusion. Around 99.7% of the iPad, it can last more than 9 hours. Okay, because if we use 3 standard deviation, I write it on the top. Okay, standard deviation is equal 20 minutes. So 3 multiply standard deviation, that is 1 hour, right? 3 multiply 20 minutes is equal 1 hour. So between 9 hour to 11 hour, I have 99.7% of iPad. I can guarantee their battery works in this time interval. So I can get a quick conclusion. I have more than 99% of observation. For more than 99% of iPad, the battery can last more than 9 hours. Okay, so this can be used for the quality control. And similarly, if we have like manufacturer for laptop, and for the laptop, if for the laptop, for how about for the screen of the laptop, is a 17-inch, and for the dimension of the laptop is normally distributed 17-inch, and with standard deviation, the mean 17-inch, standard deviation equal 0.2 inch, 17 inches, okay, and the standard deviation is equal 0.2 inch, okay, so we can get a conclusion. We have more than 99% of the laptop with the dimension, with the screen dimension is bigger, is between, how about I just give you between, is between 17 minus 0.6 to 17 plus 0.6 inches. We have 99.7%. I can control the screen, the dimension of the screen is between this interval. So it's very, very rare. I claim my laptop, the screen dimension for my laptop is 17 inch, and for a customer get a laptop with 16 inch for the screen. It's very, very rare because normal distribution, the empirical rule. Okay, so for the application for empirical rule is on the quality control, and also who is good at memorizing the definition of words, or good at remember the numbers. So you could read this part. Okay, read this part. And now I will build a connection with a graph with the word definition. That is the chart for empirical rule. And here is the empirical rule, which is given in details by number and word. Okay, so we have 68% of observation. And also we can call the area under the curve within plus and minus 1 standard deviation. So we can write it like, I don't know why this part it doesn't show up. If you have look at the slide on Blackboard, if you download the slide, it show you this mean plus minus standard deviation. Okay. And for this part, that is mean plus minus 2 standard deviation. This part is mean plus minus 3 standard deviation. I import the slide into an app, and I don't know why it doesn't show up the formula. Okay, so you could download the PowerPoint on Blackboard. It will show the formula. And for 68% of observation within 1 standard deviation, I use SD short for standard deviation. Okay, and we have 95% within 2 standard deviation. We have 99.7%. So practically, if you calculate the probability, that is approximate to 1, right? So we can say almost every observation within 3 standard deviation area. So it's very, very rare to have one observation outside 3 standard deviation area. Okay. So now I will. Do you have any question about empirical rule? No problem. If you don't have question, I will show you one example about how to use the empirical rule, okay, to solve some problem for normal distribution. How about we have a look at this one? Okay, now I will talk about how to solve the problem. I hope I have give you enough time to read the question. Okay. So this question, if you get a question like this, no matter from your homework or from the test, quickly search the keyword normally distributed. Okay, mean 20, standard deviation 5 gallon. Okay, so this is all information we have regarding the background for this problem, right? So we have the x is normally distributed with mean. I translate this into mathematics language. The mean equal 20, standard deviation equal 5. And for part A, we want to find 68% of daily water usage per person in Hamden lies between what two values? If you see this probability, okay, so if you see 68%, 95%, 99.7%, if you see this number, this gives you the idea. This is a special percentage. This percentage regarding 1, 2, 3 standard deviation. Okay, so we want to figure out 68% of the daily water usage per person in Hamden lies between what two values? I don't know what's that two value. I'm looking. I want to draw a bell-shaped curve. So my bell-shaped curve look like this. So my x follow normal distribution with mean equal 20, standard deviation equal 5. I want to find the two numbers. And for this two number, how about I use AB to denote? I want to find the AB so that between AB, I have 68% of observation. Based on empirical rule, I know A is equal mean minus standard deviation, B is equal mean plus standard deviation. So that is 25, 20 minus 5, 20 plus 5, so that is 15 and 25. Okay, so our conclusion will be we have 68% of the daily water usage per person in Hamden lies between 15 and 25 gallons. That makes sense? So similarly, I can change this question a little bit. Could you find 95% lie between what two values? Could you find 99.7% lie between what two values? 95%, that is mean plus 2 standard deviation. So that is 2 multiplied 5. So that is 30. And mean minus 2 multiplied 5. So that is 10. And for 99.7, that is 20 plus 3 multiplied standard deviation to 20 minus 3 multiplied standard deviation. If that makes sense? So if we say special, percentage, or probability, or proportion, if we say 68%, 95%, 99.7%, we will consider to use the empirical rule to solve the problem. If you have any question, you can unmute yourself, talk with me. Or you can type in your question into the chatting window. No problem? Okay, so if you don't have problem, we have some follow-up regarding this example. So I still use the example for the water usage in Hamden. Okay, now I don't give you the percentage. I want you to find the percentage. I want you to find the probability. How to find it? Okay, so we have a list of problems, and I hope you can try it. I will give you, how about I give you 5 minutes? Okay, we have 1, 2, 3, 4. We have four parts. So I will give 5 minutes. You can try it by yourself, and then I will talk about how to do it. So for this question, we had the same information, right? X follow normal distribution with mean equal 20, with standard deviation equal 5. We had the same information. We are looking for probability. And if you have a look at the knowledge, have a look at the note from chapter for the chapter regarding continuous random variable. In that chapter, I keep on talking about if we are looking for probability, no matter it's a uniform distribution or exponential distribution, draw the graph of the density function, right? Draw the graph. It will help you a lot in figuring out the probability. So for this question, I can also draw the graph. The graph for normal distribution is a bell-shaped curve. The mean is equal 20. Standard deviation is equal 5. So I can quickly get this is mean minus 1 standard deviation, mean minus 2 standard deviation, mean minus 3 standard deviation, mean plus 1, mean plus 2, mean plus 3 standard deviation. Do you agree with me? Okay, so I want to find the probability. So if we are looking for probability for continuous random variable, draw the graph. It will help us a lot. Okay, draw the curve or draw the graph. Very important. And now I can go over the question one by one. What is the probability that a person selected at random will use less than 15 gallons per day? 15 gallons, so this is 15 gallons. Less than 15 gallons, so I'm looking for the area for this part. Right? So 15 gallons per day is equivalent to, I'm looking for the probability for X less than 15 is equal the blue color shaded area. I'm looking for this area. And how to find this area? Now I should use empirical rule because it's related with 15. 15, that is 1 standard deviation. And for empirical rule, it doesn't give us less than 15 what happened, but it gives us between 15 to 25. I have 68% of observation. Do you agree with me? So I have 68% of observation between 15 to 25. So it's not hard for me to get. For this part, for the green color, part is equal half of the 68%, right? Because it's symmetric, right? It's symmetric with this line. So for the green color part, I have 34%. And for the green color part, I have 34%. And based on the definition, the characteristic for normal distribution, I know this is the mean. And less than the mean, I have 50% of observation. So for the yellow part, I have 50% of observation. Okay, so for the green part is 34%. The blue part is equal the yellow part minus the green part. Do you agree with me? So we have a look at the area for the yellow part, the green part, and the blue part. We can find out the blue part add the green part is equal the yellow part. So blue part is equal the yellow part minus green part. And for blue part is equal 50% minus 34%, which is 16%. So that's all. Did that make sense? So draw the graph. And then if you are looking for specific part, use your pen to shade that part to let yourself know which area we are looking for. Okay, and maybe sometimes the area you're looking for, you cannot use empirical directly. You need to do some transformation. You need to use some geometry knowledge. Use the area for this part, subtract the area for another part to get that area. Did that make sense? For the first part of this question, if you feel confused, you can unmute yourself, talk with me. I can repeat this part. Or you can use the chatting window to let me know if you feel confusing about this part. No problem. So this is part 1. The second part, how to find the probability more than 30 gallons. More than 30 gallons. So I will erase this part, erase the solution. If you don't have question, I will erase the solution, okay? And for second part, I still draw the bell-shaped curve. Okay, the mean is 20. Standard deviation is 5. And for 30 gallons, more than 30 gallons, so 30 is here. That is 2 standard deviation. We are looking for the probability for more than 30. Probability for x bigger than 30 is equivalent to, how to find the area for this part? So we use the same technique as before. For the green part, for the green color part, is equal the red color part. Okay, I use red color, subtract the blue color part. Okay, and for the red color part is equal 50% for the red color part. And for the blue color part is equal 95% divided by 2. Do you agree with me? Because between 10 to 30, we have 95% of observation. So between 20 to 30, we only have 95% divided by 2%. And the difference between them is the answer for this question. We can use a calculator to calculate 95%. What is the value for 95% divided by 2? So it's equal 2.5% after calculation. This is part B. Part 2, the second part. Any question about this part? No question? If you don't have question, I will do the next part, the third part. Okay. If you don't have question, I will erase the solution. Okay. I will erase the solution and do the third part. The third part, the percentage between 15 to 20. Still start with a bell-shaped curve. 20 is here. 15 is here, right? So between 15 to 20 is half of this 68%. Between 15 to 25, we have 68%. Between 20 to 15 is half of this 68%. So that is 34%. For part C, it's pretty easy, right? Pretty straightforward to get. And for the last part is how to find the percentage between 10 to 25. Between 10 to 25. So this is 10 to 25. I use the blue color. Between 10 to 25. How to find this? It really depends on how you divided this graph into small pieces. Okay, so the method is not unique. I can divide this graph into two pieces. This is the first piece, this is the second piece. Okay, I can also divide this graph into two pieces in this way. This is the first piece, the green color part. Because this part I have 68%. And calculate this piece. Okay, so it doesn't matter how you divided this red color shape into small pieces. Okay, and how about I use the green. I use the method for the green color. I divided it into two pieces based on the green color and the yellow color. Okay, so for the blue color is equal. The blue color is equal the green color plus the green color plus the yellow color. Right? So for the blue, that is something we are looking for, is equal the green color part plus the yellow color part. The green color part is equal 68%. That is one standard deviation. So that is not hard to find out. Right? So now the challenge part for this question is how to find the yellow color part. How to find this? Okay, how to find this? We know from here to 30, okay, within two standard deviation area, we have 95%. Do you agree with me? And for this 95%, if I subtract the middle part, 68%, I subtract this part, I can get the yellow color part plus this part. And because the area for this part is equal to the area for this part. Could you follow me? So the area for this part, how about I suppose this number is equal A. If this number is equal A, this number also equal A. So it's kind of 2A is equal 95% minus 68%. 95% minus 68%, that is equal 27%. So for the yellow color area, is equal 27% divided by 2, half of the 27%. So my final answer will be 25% divided by 2 plus 68% is equal 81.5%. So this is the final answer. Okay, you can also try the first method. The first method, I divided into two pieces. The first piece is this part. This is the first piece. And the second piece is this part. This is the second piece. You can also try it in this way. It will give you the same answer. Okay. So this is the answer for this question. If any part you feel confusing, you can unmute yourself, talk with me, or you can use the chatting window. You can type in the number for the part. So this is part 1, part 2, part 3, part 4. Which part you still feel confused, you can type in the number into the chatting window. If you don't have question, I will talk about another technique to find the probability. Okay, so if you have any question, you can type in the number into the chatting window or unmute yourself, talk with me. No problem. For your next exam, we will have one question very similar to this. Okay, use empirical rule to find the probability. Okay, I didn't see any question. I will move on to talk about another technique. Okay, I will erase this solution. And just now we talk about example 3. Okay, and for example 3, we can find out no matter the question related with 15 or 30 of this number 20, 10, 25, they all related with mean plus minus 1, 2, 3 standard deviation. Right? If I'm looking for the percentage for the general number, like 16, 22, which we cannot use mean plus minus 1, 2, 3 standard deviation, how to find the probability? How to find the probability like between 29 to 43, something like this. I cannot use mean minus plus 1, 2, 3 standard deviation to rewrite this number. If we have a question like this, how to find the probability? Okay, so I will show you how to use a calculator to find the probability. Okay, so we will talk about how to use TR 83, 84. We still use water usage example. Okay, for the water usage example, x follow normal distribution. The mean equal 20, standard deviation equal 5. Okay, now I want to find the probability for x between 16 to 22. How to find this probability? There is a function in the calculator. If you have calculator with you, turn on your calculator, you can follow me. Okay, I will show you a function. Could you see my calculator? Thank you. So press second and then distribution, VARS. Okay, so exactly the same button you used for binomial distribution and Poisson distribution. Okay, second VARS. And then you will find out there are a couple of functions related with the normal distribution. The first one is normal PDF. The second one is normal CDF. And the third one is RNV. We call it inverse function for normal distribution. Okay, and for our class, we will use the second one and the third one. And for the first one, we never use it. Okay, be careful about this part. For the first function, it's kind of a garbage function. We never use it because for PDF, it's related with the probability for x equals something. The probability for x equals something is always 0. Okay, so don't use that function. And for this question, we are looking for the probability for x between 16 to 22. Okay, I will use CDF, normal CDF, to find the probability. Okay, so the same as other continuous random variable, we only use a CDF to find the probability. PDF cannot help us to find the probability. PDF can find the probability for discrete random variable. So I highlighted the second function and then press enter. Okay, once you press enter, you can see my calculator gave me this output: lower, upper, mean, and standard deviation. For lower, that is a value for your lower bound. I'm looking for the probability for x between 16 to 22. So 16, that is your lower bound for x, right? That is the minimal value for your x. If x less than 16 is not event into my consideration. And for the upper is 22. So I input 22. Lower upper, the mean is equal 20. Standard deviation is equal 5. And then press enter. It will give you the probability. Does that make sense? So we can try one more. Could you find the probability for x between 23 to 27? 23 to 27. Okay, I will do it one more time. So press second, use VARS, and then use the second function, normal CDF. Okay, 23 is my lower. I want to find the probability between 23 to 27. So 27 is my upper. The mean standard deviation, I don't need to change. Still equal 20 and 5. So press enter. It will give me this output, 0.1 something. Could you see it clearly? So this is the output from my calculator. 0.1935. Let me know if you cannot get this probability. You can unmute yourself, talk with me. I will do it again. This is very important. And for your second exam, you will have one big question from normal distribution. Okay, so if you don't have a problem about this, now I will talk about some general scenario, how to find the probability. We will use normal CDF. Okay, we use normal CDF from our calculator. And if you use normal CDF, always follow this order. Input 4 numbers. Lower, or you can call it minimum value for your x. Upper, that is maximum value for your random variable. And then mean, and then standard deviation. Mean standard deviation will always give you. If we are looking for the probability for x between like 10 to 20, you can try this question. Input 10 as your minimum, input 20 as your maximum, and then mean equal 20, standard deviation is equal 5. So it's much easier than empirical rule. You just press several buttons. Okay, but for empirical rule, if you don't have a calculator with you, you can use empirical rule to help you roughly get the probability number. Okay, so if you don't have question, I will stop here. And for tomorrow, we will talk about how to use R to get probability for different types of distributions. Okay, so tomorrow we will have lab. Okay, enjoy the rest of your day. If you have any question, unmute yourself, talk with me. I will give you more practice Tuesday. Okay, for this part. So we can use almost the same technique, right? This one, x less than 92. X less than 92. We have upper, right? I still use normal CDF. And I have upper. Upper is 92. This is the maximum value for x, right? And I don't have lower. I don't have a lower. I will consider my lower will go to negative infinity. Just now we use 10 to 99 to represent the positive infinity. So for the negative infinity, we will use negative 10 to 99. And then mean, and then standard deviation. That makes sense? So now I will use my calculator. Where is my calculator? Here. Normal CDF. Normal CDF. Lower is negative. So Be careful, negative sign is here. Okay, use this part. Don't use this. This is not negative. This is negative. Negative 10 to 99. And for the upper, we are looking for the probability for x less than what? Cannot remember the number. Less than 92, right? So for my upper is 92. And for the mean 100, standard deviation is 5. So press enter. It will give you the probability. Did that make sense? So just use a normal CDF to find the probability for normal distribution. If you have any question regarding this part, you can unmute yourself, talk with me. No problem. How about I give you more practice? I'll give more practice for this part. This is an example for could you find the probability? We have standard normal distribution. Okay, for Z, follow standard normal distribution with mean equal 0, standard deviation equal 1. Could you find the probability for Z between 0 and 1? Could you find the probability for Z between -1 to 1.5? Could you find these two probabilities? Two questions. Okay, so don't have a look at my answer. I will erase my answer. Okay, so don't see my answer. Try it by yourself. This is very, very important. If you don't know how to use calculator to find the probability for normal distribution, okay, so chapter 6 and chapter 7 is you cannot get any credits. It's so hard to get any credits. Majority of the question regarding how to use a calculator to find the probability, and if probability is given, how to find the random variable value. For chapter 6 is about normal distribution, and for chapter 7 it's still normal distribution. Okay, and for our test we focus on chapter 5, 6, 7. So if you don't know how to use this function, it's hard to pass the test. Okay, so if you have any question, unmute yourself, talk with me. How to use a calculator to find the probability. Or you can type in your question into the chatting window. I'm reading the message from the chatting window. Okay, so for this one, now I'm sharing my calculator. Okay, so normal CDF, and because our distribution is standard normal distribution, right? So standard normal distribution, that means the mean is 0, standard deviation is equal 1. They are special normal distribution. We have special value for the mean, special value for the standard deviation. And for question 1, we want to find the value for Z between 0 and 1. Z between 0 and 1. So for my lower is 0, for my upper is 1. So I press enter. It's give me 0.34. 0.34. Okay. So I get 0.34. I will use this part. I get 0.34. And if I don't use a calculator, if I still use the method we covered before, our random variable follow standard normal distribution, we could draw the curve. The mean is 0. Standard deviation is equal 1. We are looking for the probability between 0 to 1. So for this question, it's not necessary to use a calculator. If you use empirical rule, you can still solve the problem because 1 is a special number. That is mean plus 1 standard deviation, right? And from -1 to +1, for this part, we have 68% of observations. So for this part, we only have half of this 68%. So that is 34% of observation. So calculator or empirical, they will give us the same answer. Did that make sense? So if you have a question like this in your test, if I didn't give you instruction like you have to use empirical, you have to use a calculator, you can do both. Okay, but for part B, how to find the probability? What is that probability number? It's covered by my. So we input the mean and the standard deviation. And for the first input, that is the area, that is a percentage to the left side. Okay, be careful, left side. Every semester I have students input the right side. Once they saw 50%, they just use 15%. That's so wrong, because if you use 15%, it's kind of majority of students can get A in this class. We have 85% of students can get A in this class. Okay, so this K is here. We have 85% of observations less than this K. So we input 0.85 or 85%, and then mean standard deviation. And it will give you the output. It's 77.2. So if a student gets 77.2 or higher, this student can get A in this class. Did that make sense? Do you have any question about this part? Okay, if you don't have problem, this is the last part for this chapter. Okay, I have 10 minutes, so I can finish this chapter. So at the end of this chapter, we will talk about a special notation. Okay, and for this notation, it's Z sub A. Okay, so it's not like this. So it's a good idea before class you can download the PowerPoint from the Blackboard and you can read the PowerPoint, or during my lecture you can use your computer to see the PowerPoint. You not just see the screen I'm sharing, because the screen I'm sharing sometimes it give us the wrong format. Okay, so it should be Z sub A. Z sub A is not Z capital A. Okay, it's a Z sub A. And the notation of Z sub A. And the reason we need to talk about this part here, because for chapter 8 and chapter 9, when we're talking about the confidence interval, when we do the hypothesis testing, we need to use this. Okay, so for the inferential stats part, we need to use this notation. And what's the mean of Z sub A? For Z sub A, it represents we are looking for a value. Z sub A is a random variable value. Okay, so that to the right side of this value, we have the area equal A. Okay, so for example, if I'm asking you, could you find Z 0.95? You can use inverse norm, mean, standard deviation, because it's Z something. It's z something, so the mean standard deviation always is 0, 1. Okay, we don't have this notation. X sub a, it is not useful. It's not common, very, very uncommon. Okay, but for and if you see this notation z sub a, could you see my handwriting? Could you see my handwriting for z sub a is, so in the future, if you see z sub a, you just use the inverse norm function. For the first input is 1 minus a, 0, 1. So it's just a notation, but for this notation, it represents special random variable value. And how to find this special random variable value? We always use this function, use the inverse norm. And the first input is 1 minus capital A, and then means standard deviation. What I write? So how about we have some practice for this part? How to find z sub 0.025? If we are looking for this, we just use the inverse norm, 1 minus 0.025 as your first input. Your second input is 0, your third input is 1. Okay, and also it's a good practice to try z.1, z.05, z.01, and z.005. For our first exam, I found out during the exam, majority of students they turned on their camera, and there are 5 or 6 students they didn't turn on the camera during the exam. So it's kind of unfair for students who already turned on the camera, right? So if you mute your camera for other students, they turn on the camera, it's kind of unfair. So I'm thinking of maybe for the second test, because I think maybe it's you I understand maybe you have some reason you don't want to turn on the camera. So for the second test, for students who turn on their cameras, I will give you some bonus points. Okay, so I think that will be fair for students who turn on the camera. If you don't want to turn on the camera, you cannot get a bonus. And for students who turn on the camera, I will consider to give several points bonus for the second exam. Okay. Okay, so I noticed there is a question in the chatting window. Can you give us more time for the exam? Rush on the first exam. So, give more time. That is, I don't think so. I don't think I can give more time because our class is scheduled from 3:25 to 4:40, and I believe some students maybe they have class previous to our class or have class after our class. So if I give extra time, if some students they need to go to another class, it's, they cannot take advantage for the extra time. So I need to give. I still need to use the same time slot for our class, but I can consider give you a shorter exam. So maybe for the for the first test, I think for the first test it's not very long, right? We have 16 short multiple choice and 5 short answer question, right? You You have question. You have difficulty uploading picture. Hmm. Hmm. How about there? I got another comment from students. How about if you don't have enough time, you feel your time is up, you can you don't have to like take a picture for your solution and upload immediately by Blackboard. You can take a picture and email me, so that cannot give you extra time. But you please don't return to me too late. If our exam uh, ends at 4:40, so you cannot send me the solution like 8 p.m. or 9 p.m. That's too late. So if you can send me the solution before 6 o'clock, I think that's still acceptable. Is that good? Shorter, okay, so more comments. Did good. Yeah, I will consider give shorter exam. Maybe for this time I will just give you maybe 10 multiple choice question and give you 5 short answer question. But I still need to make sure for the test it can uh, really assess your performance. So I need to make sure the test cover all the objectives for the for chapter 5, chapter 6, and chapter 7. I will not give you like a redundant question. So how about 10 multiple choice question and 5 short answer questions? I think that will cover almost everything for chapter 5, 6, and 7. But for short answer question, prepare. So for every question, we have multiple parts. Okay. Okay, so that's all question I got from the chatting window. Any other questions? If you have any question, you can unmute yourself, talk with me, or you can use the chatting window. So everything is good? Okay, so I didn't say more questions from the chatting window. Okay, so I assume you don't have any questions. Okay, I will keep on talking about chapter 6. If any question come from your mind, you can still use the chatting window and type in the question, and I will check the chatting window regularly. Okay, and for chapter 6, let me find the empty paper. So how about I Okay, now I will talk about them one by one. Okay, we have some keywords for this question. At first, have a look at this keyword, normally distributed. Okay, so this gives us clue for this question. We cannot use the exponential distribution. We cannot use the Poisson distribution. We cannot use other distributions. We will focus on normal distribution. Okay, and if you see this keyword normally distributed, so two functions come to your mind. The first one is a normal CDF. The second one is inverse norm. Okay, so you will use them. And this question, our mean, the average is 66. The standard deviation is 2.5. So our random variable x follow normal distribution with mean equals 66 with standard deviation 2.5. So this is the information we could get when we read the question. And for this word problem, we can translate to this mathematics language. And then we can go over all the questions. For A, find the probability. Probability, we use capital P to denote the probability. For the height between 65 to 69. So for the question we translate into mathematical language, it will look like this. We are looking for the probability for x between 65 to 69. We are looking for probability. We should use normal CDF. If probability is given, we use inverse norm. If we are looking for probability, we use normal CDF. And for normal CDF, we need to take 4 inputs. And for this 4 inputs, 65, 69, my minimum, my maximum, and my mean is equal 66. My standard deviation is 2.5. So input this 4 number, press enter. It will give you the probability number. Okay, so if you access to Blackboard, download this PowerPoint, you will find out for the next slide. I already gave you the output. You can compare the output from your calculator. Okay, and for part B, would you expect to meet many adult males over 72 inches? So for this question, it's about, do you think you will? So I can read this question like, do you think you will have a high chance to meet adult over 72 inches or not? So if the chance is big, then we expect to meet many adult males over 72 inches. If the chance is very small, then we will not expect to meet many. Did that make sense? So this question is equivalent to, could you find the probability for x bigger than 72? And what is the output from this? So x bigger than 72, my lower is 72. So I still use normal CDF. My lower is 72. My upper, I don't have upper. I will use 10 to 99 as upper. For the mean, it gives us. For the standard deviation, it gives us. And if you input this into find out the probability number, it's a very small probability number. If you get a very small probability number, I cannot remember the number from my output. How about I quickly use my TI-8384 calculator. Normal. I will show you that probability. X bigger than 72. Is mean equal 66. Okay, so my calculator gave me this output. When x bigger than 72, means it gives me this output, 0.0082. So that means if there are 1,000 persons, I only have roughly 8% with the height over 72 inches. So it's very, very rare. It's not common. So we don't expect to meet many. That makes sense. For every 1,000 people, we only have 8 people. We only have roughly 8 people with a height over than 72 inches. So that's why this one, our answer will be no. We don't expect to meet many. And why? Justify your answer numerically, so you can just report me this probability number. That makes sense? So this is part B. And for part C, the middle 68.27% of heights fall between what two values? So we are looking for two values. And for the middle 68.27% of heights between these two numbers. Okay, so if I translate this into a graph, it's equivalent to, could you find the number A, could you find the number B, so that between AB and between AB we have 68.27% of observations. If you have a look at the empirical rule, you will find out one standard deviation area we have roughly 68% of observations. So for this A value, it will be mean minus one standard deviation. For this B value, it will be mean plus one standard deviation. So we will have 68% observation between these two values, this one and this one. And you can calculate and get the value of AB. And this question, it gives us the special percentage. If it gives us 68%, 95%, 99.7%, we could use the empirical rule. If I change this question a little bit, okay, so how about I change this to this? So how about I call this a C? This is question C. How about I revise this question a little bit and give you C plus? Okay, so for question C plus, if I change this to the middle, how about 54% of heights fall between what two values? How to answer this question? If I don't give you a special percentage, if I just give you a general percentage, any percentage, 54, 58, 62, 79, something. So it's not empirical related percentage. How to answer this question? So for continuous random variable part, always draw the chart. It will give you a clue. Okay, so if you get a question, you don't know how to do it, you really don't know how to start with, draw the chart. Okay, so we are looking for two values. How about this value is A, this value is B? We are looking for AB. The middle, we have 54%. Okay, so we are looking for A, we are looking for B. Now my question becomes, could you find the percentage of this part? If you can find the percentage of this part, the value of A will be very easy to get. The value of A will equal inverse norm the area for that part. If this part I use a question mark to represent, I need to find this area and input here. and the mean 66, standard deviation 2.5. Right? So now question become how to find the question mark, how to find the green color shaded area. For the blue color shaded area, we have 54%. And for the green color shaded area, add the red color shaded area is equal 1 minus this 54%. Do you agree with me? So the blue color plus green color plus red color is 100%. And we know blue color is 54%. So that means green color and red color, we have 46%. And because normal distribution is symmetric, so for the green color shaded area is equal half of this 46%, that is 23%. So I can use the inverse norm, 0.23 or 23%. So you can input the decimal number or you can input this percentage as your first input, and then mean standard deviation. It will give you the value of A. Okay, that makes sense? Once you get the value of A, how to find the value of B? We could use two methods. Okay, for the first method, I still use the inverse norm. My second input is 66, my third input 2.5. And for my first input, I need to find the area to the left of B, right? The area to the left of B is equal the blue color part plus the green color part. The green color part is 23%. The blue color part is 54%. So we can calculate the first input will be 23 plus 54, which is 77%. Or you can use 0.77 as your first input. Input this number into calculator and then press enter. It will give you the value of B. So this is one method. You still use inverse norm. The second method, if you don't want to use the calculator again, okay, so you can have a quick look at the relationship for A and B. So this is A, this is B, and they are symmetric with respect to the mean, right? And for the mean is equal 66. The mean is equal 66. And for the mean is kind of the middle point for A and B. So A plus B divided by 2, that is a middle point. And the middle point value is equal 66. So the value of B is equal to multiply 66 minus the value of A. So whatever you got from the calculator for the output of A, you use to multiply the mean minus the output from A. You will get the value of B. Okay, so you can say if you use the second method, you don't need to use inverse norm again. You can just use the inverse norm to find the value of A, and then use the property for symmetric. You can get the value of B. Okay, but for the second method, it really depends on your right solution for A. If you mess up for A, if you made a mistake for A, then it will lead your wrong solution for the value for B. Okay, so we need to be very careful about that. That makes sense? So this is part C. And for part D, part E, they all related with a percentage is given, right? We have 90%, we have 60%. A percentage is given. We are looking for the height. The height is our random variable, right? So we give percentage, we are looking for the random variable value. We should use inverse norm, right? So how about I erase this part? I will erase this part. And write the solution here. So for part D, draw the graph. And we are looking for a height. and we want 90% of adult fall below that height. So if this height, I don't know the value of that height, I suppose it's k inches. We want 90% of the height of the adult male fall below this value. So below this value, so it's kind of, we want this 90% of observation less than this value. So this part is equal 90%. I have 90% of observation less than this value. We have the area, we have the percentage to the left of the value we are looking for. So I can use this 90% directly, right? Inverse norm, the first input 90%, the second input is the mean, the third input is standard deviation. So this is part D. And for part E, I will draw another chart. For part E, I still use bell-shaped curve. I still use K. I don't know where is K, so I just find K randomly. And then I read the question. I want 60% of adult above this value, right? So this is our keyword. The height, we want to find a height. We have 60% of observations above this value, so it's bigger than this value. We have 60% of observations bigger than this value. Then we will have 40% of observations less than this value. So my inverse norm, my first input should be 40%, and then mean, and then standard deviation. Because when we use normal inverse norm, we need to make sure our first input is the area or is a percentage to the left of the value we are looking for, right? So we need to transform to 40% and then use inverse norm. And after input everything into calculator, it will give you the output. You will give us the output. So you can check your output from calculator and compare yours with mine. Okay, so this is a complete example for chapter 6. If you have any question about chapter 6, you can unmute yourself and talk with me, or you can type your question into the chatting window.